Hello, this presentation continues our examination of the Anthropocene and some of the challenges that humanity is facing in the very near future, and we're going to start using cooperation to see how we could possibly solve some of these challenges. So we're discussing four big booms in the Anthropocene. We've already discussed the population boom. In this presentation, we'll look at changes in energy consumption, food production and consumption, and changes in social inequality. So if you remember, we discussed how population growth has increased exponentially since the industrial age, and how we're now over 7 million people on the planet and possibly exceeding 8 million by 2025. So populations worldwide have increased very rapidly, very quickly compared to the rest of human history. And mirroring that change in human population growth, we've also seen an exponential increase in world energy consumption, not just with biofuels, but with coal, oil, natural gas, and other forms of energy production. And this is both the population growth and the energy consumption is linked to industrialism. During the industrialization that occurred starting primarily in the 1800s, since then we've been constantly harnessing new energy sources and, more importantly, making more stuff. So for most of human history, the energy sources that were available to us were either biomass, like firewood, for example, or human and animal power. And if you've ever worked on a farm or had to dig up your garden, you know that the amount of energy comes out is not a whole lot more than the energy that goes into doing something like plowing a field. With the invention of things like wind and water mills, all of a sudden we could harness the energy in natural resources like the flow of a river to do things like grind grain, mill textiles, and increase the amount of stuff that could be output and minimize the amount of human energy that was input. And this has increased with the harnessing of fossil fuels like coal and natural gas and oil. And since the industrial era, we've just seen a boom in the increase in the use of these fossil fuels. So coal was used very, very small percentage in 1820, and you can see how much it has increased, and this is a measure of energy output up until the year 2000. Same thing for oil and natural gas as well. Biofuels have only marginally increased in the amount of energy they're used to produce each year, but in a lot of areas, even a marginal increase has resulted in a lot of deforestation of natural areas, for example, as people continue to cut down trees for firewood so they can do things like cook their meals and boil water. And the result has been an expansion of a vast amount of stuff, things like material goods. This is a Japanese girl living in Tokyo, and these are the items that are in her bedroom, so quite a change from even 100 years ago. The amount of light that's produced. So here is a map of the United States at night from space, and here is all of the bright electric lights that you can see in our cities today. Space, in terms of the average size of an American house from 1950 to the year 2000 has increased. It's almost doubled in size, and we need room to put all of that stuff that we have now. And also energy. There are currently 10 billion electronic communication devices in the world today, so things like cell phones, and most of these devices use some sort of internet, and just powering the data centers that you access through the internet takes up about 2% of global energy. So just powering all of these larger spaces, more lights, the production of more material goods. So another word for the Anthropocene, or another term for the Anthropocene, has been the exponential age, where we see more population, more energy, and also more food. So industrial intensification has increased food production 6 times, while increasing the area of cultivated land by only 33% in the 20th century. So for example, in 1950 in Iowa, one farmer could produce enough food to feed 250 people. Fairly impressive. In 2000, that same farmer in Iowa could now feed 500 people. So we're seeing new levels of intensification. We're seeing more food produced per unit of land. And in the U.S. in particular, food surpluses are huge. And in fact, about 50% of the corn in Iowa that's produced goes to feed cattle. So not only the consumption of vegetable material, but the consumption of meat, which is fueled by that meat-eating vegetable material, has increased and continues to increase around the world. And how can we do this? Well, these new energy sources like fossil fuels, they power the machines that grow, process, transport, and prepare food. So those tractors that plow the field, the machines that process the corn, the trucks and trains and airplanes that transport it, and even the energy to run your microwave to heat up your mac and cheese. Also produced by fossil fuels that increases the food output per unit of land are synthesized fertilizers. Artificially produced nitrogen, for example, that's pumped into those corn fields is produced from fossil fuel, and these fertilizers increase the production of the plants. We've also seen higher yielding crops developed, so either developed through artificial selection or even genetic engineering. The production of pesticides, herbicides, fungicides, chemicals that reduce all of the pests, funguses, and weeds that try to attack these crops are also produced with fossil fuels. And finally, much higher water inputs. Water has to be pumped out of the ground, it has to be transported, in many cases it has to be cleaned, and all of these take energy. So these booms in population and energy are closely tied to booms in food production systems. And one result of farmers being able to feed more people with the same amount of land is that we're seeing increasing urbanization. Today, only 2% of Americans live on farms. This is very different from 200 years ago. And about 80% of Americans now live in urban areas, and this is a world trend. About 50% of people worldwide now live in urban areas. And in fact, some of these urban areas are so large that they're called megacities. And we have 24 megacities on the planet with populations over 20 million people. So almost 500 million people live in just 24 cities. And you can see how this urbanization has increased over time. This is a map of Chicago and where people were living in Chicago from 1850 until 2001. And you can see the little dark dots on the on the edge of the lake here, the charcoal gray dots. These are where people were living in 1850. You can see but the bright yellow, where people have expanded to in 1871. The bright red represents 1945, so even just 100 years later. And the purple and dark magenta represent the size of Chicago today. So you can see how the city has just exploded in terms of size. And this means increasing things like roads, city services, and of course all of these people are consuming food, water, energy, and other stuff. And this is a worldwide trend, so here's the growth in Los Angeles. You can see where that star in the middle is. That's the original LA population in 1877. By 1937, you can see the light orange, and 1970, the dark red, 1989 and 2000 in the purple and dark magenta. So LA has just expanded, and remember, LA is in the desert. There aren't a lot of local resources, so many of the things that these people are using, like water, are being transported. And in fact, California buys water from a lot of other states, and California was trying to buy water from Idaho not so long ago, even though a lot of our state is considered to be a desert as well. Here's Lagos in Nigeria. So 1850, the little yellow you can see down there at the bottom. And since 1950, and particularly in 2000, the city has just exploded in how many people are in this urban center now. Mumbai, India, there's the original population in gray at the bottom. And recently, post 1955, and especially since 1992, the city has just exploded. Same thing in Shanghai, China. So we've just seen massive amounts of increasing urbanization as rural farmers can produce more food to send into the cities to feed people in non-food producing jobs. And one of the consequences of these changes in residence patterns in food production has been inequality. If you look at the population growth rates around the world, you can see that we have some countries who are out-reproducing others, and the industrialized countries are those that have decreased their population growth rates the most, like the United States and Europe. But population growth is definitely a cooperation problem that people are going to have to face, and even if we think in terms of just strictly natural selection, reproductive success is out-reproducing everyone else. So it's definitely a cooperation problem and an altruism problem to ask people to give up their reproductive success for the good of the global population, for example. Food, this is a map of obesity rates worldwide, and you can see that there is definitely an unequal distribution in which countries are hypernourished and in fact overnourished so much that they're now experiencing a lot of health problems. So the orange and the red countries, and you can see there on the Arabian Peninsula that some countries have caught up or exceeded the United States in global obesity, and some countries are not. And so we see here a map of countries with stunting in children. So these are high-burden countries. Children who are undernourished can't grow adequately, and so their height is stunted as adults. So adult height is a marker of a biological response to undernourishment and malnourishment as children, and you can see this is not equally distributed around the world. So achieving food parity, parity is also a cooperation problem. And when you look at the global economy, you can see exactly how unequally distributed the growth in wealth has been compared to the population growth. So this is a map of the world, and you can go to the site worldmapper.org and ask it to distort all of the countries in the world according to different criteria. And so these countries are showing you the difference in how much each person earns versus how many children they have, and you can see that Western Europe, the United States, and in fact a lot of areas in China, the wealth has exceeded the population growth. But there are many areas highly underrepresented. In fact, most of Africa is not even visible. We really only see South Africa. And the World Bank has stated that a country's gross national product per capita tends to be closely linked with other indicators that measure social, economic, and environmental well-being. So people in countries with higher gross national product, like the United States, have longer life expectancies, higher literacy rates, better access to safe water, and lower infant mortality rates. So many of the things that make life good are highly tied to the country's gross national product. And this is very unequally distributed around the world. And so an anthropologist did an interesting photojournal project where they went around the world and took pictures of families with the amount of food that they would purchase for the week. So this is a family in North Carolina, USA. Here we see a family in Sicily, Italy. You can see that the diets are considerably different, and the Sicilians have lesser amounts of food per person, just out of food preferences. But some countries have significantly less access to food. So Chad, which is a country in North Africa, we can see here that each individual has significantly less access to food than the family in North Carolina. And same thing for many countries around the world. And you can tell just from the background that access to less food is representative of access to less of other services like heating and cooling, books present, access to media, access to potable, clean drinking water. So obviously, most people would like to reduce social inequality, but that's a big question of how to do this. The answer for the past several decades has been to industrialize and develop countries who have less resources per person. But one problem with industrializing everyone is that you're increasing things like atmospheric change. So if the whole world was like the United States, carbon emissions would soar fivefold. And many scientists already think that the world is at its carbon emissions maximum burden, and that significant climate change will result in increasing carbon emissions. And all this energy is used to produce things like stuff and light and more energy. And there's a problem with space as well. So it seems like it's just untenable to have everyone living at the same quality that we enjoy today. So figuring out how to achieve global industrial prosperity as the United States experiences it is another cooperation problem. And we're going to go into our last week of class and talk about how we might be able to solve some of these large-scale cooperation problems. I hope you enjoyed the presentation. Thanks for listening.